Hello, everyone. My name is Stephen Roth, and I am president of Carmel Software, a developer of mobile applications for the built environment and also a custom software developer for large organizations such as Carrier, ASHRAE, DOE, and others. And we also oversee gbXML. Today's webinar is titled A Demo of Building Analysis and Energy Auditing Software Tools using gbXML and BuildingSync XML. And in fact, today we will be demoing software tools that integrate with both gbXML and BuildingSync XML, and also talking a little bit about gbXML, BuildingSync XML, and some of the latest ongoing initiatives. So our agenda today will be, I will be giving an overview of gbXML and BuildingSync XML, and then conclude the webcast with some Q&A, time permitting. And then Michael Sawford and Robert Yori of EDSL will be demoing their EDSL Tas desktop software tool that utilizes gbXML. And after that demo, Matt Brown of SimiWatt will be demoing the buildee tool and its integration with BuildingSync XML. And like I said, we will conclude with Q&A if we have time. So a couple of logistics, if you indeed do have some questions, there's a little question applet in the GoToWebinar main applet. So feel free to submit questions, and then at the end, I will forward to the questions to the appropriate individuals who could answer them. Also, we will be recording this webinar, and it will be available on YouTube within a couple days, and I will be sending out a link to that to everyone when that is online. So before we continue, I would like to conduct a quick poll just to see what type of audience we have out there. So let's get started with the poll. All right. So here are the poll results. Interesting distribution of professionals out there. We have energy modelers, 28%, software designers, 17%, engineers, 33%, energy auditors at 7%, and others at 15%. So a nice mix. All right. So let's get started with the overview. So what is gbXML? And I realize that this may be a review for many of you, but there's always new people attending these webinars, and also there's just new people entering our industry. So I'd like to give a brief overview of it. Now, gbXML is the language of buildings and allows disparate building design software tools to all communicate with one another. Now, building information modeling, or BIM, and gbXML are complementary to one another. So the whole essence of BIM is interoperability, getting the data out of the BIM and into other tools that can utilize the data. Now think of gbXML as the transport mechanism that allows this data to flow from BIM to external software tools and back. Now gbXML is not a programming language, nor is it a software tool. It is a structured XML schema or language that focuses on storing data about buildings. So this is all in the name of helping architects, engineers, and energy modelers to design more energy efficient buildings. And it accommodates a wide range of building analysis, including whole building energy analysis, of course, water use and cost, carbon emissions, heating and cooling load HVAC calcs, renewable energy, HVAC equipment sizing, lighting analysis, CFD analysis, and much more. So a little bit about gbXML. It's an open source and free schema. It's available at gbxml.org and also on GitHub at the Green Building XML repo. It includes a board of directors of 11 BIM authoring and building analysis tool software vendors worldwide. 54 software applications support gbXML. We're in our 20th year of gbXML. It actually was launched in the year 2000. And in fact, several research projects are currently focused on improving the gbXML workflow, which I will touch upon in a bit. And there's also a free online gbXML viewer that is regularly being updated. So let's talk about one of the research projects briefly. This one is sponsored by ASHRAE, and it is titled ASHRAE RP 1810, and the title of it is Development of Reference BIM Test Cases for Improving Usage of Software Interoperability Schemas. It's quite a mouthful, but the overall objective of this research project is to develop 20 or more geometric test cases for BIM software tools, authoring tools, to utilize to help their tools successfully export valid gbXML so that it can be used by other building performance software tools. And this research project will also create an open source web-based validation software tool that allows these vendors to upload the test files, view the gbXML models in their web browser, and receive a detailed pass-fail feedback. So the other initiative taking place, this is a newer one, is actually an SBIR grant, a DOE SBIR grant, titled Innovative Building Energy Rating Delivery Models, and this was awarded to Carmel Soft. And this project seeks to improve the interoperability of various building energy design software tools so architects and engineers can more easily and accurately design energy efficient buildings. More specifically, this tool will accommodate both gbXML and BuildingSync XML. So a brief overview of the free viewer available at gbxml.org. This is a screenshot of it. It's been out for a couple of years and we are constantly updating and improving it. And the current version allows you to upload gbXML, view it, pan, zoom, select individual elements to query them, and even edit it. And you can view it on your desktop, on your tablet, or your smartphone. And this is available at gbxml.org. All right, so let's talk about BuildingSync XML briefly. So these next couple slides are courtesy of NREL, and they actually had a demo about a month or two ago, so some of these slides come from that demo. So BuildingSync XML is a common schema for energy audit data that can be utilized by different software tools involved in the energy audit process. It minimizes duplication of effort for subsequent audits and facilitates achievement of greater energy efficiency. So use cases include importing and exporting from the Asset Score Audit Template tool, which is a web-based tool for entering building energy audit data, and submitting data to cities that have local energy audit ordinances. So you may be asking, what's the difference between BuildingSync XML and gbXML? Well, think of BuildingSync XML as focused on the exchange of energy auditing data between disparate software tools involved with commercial building energy auditing. gbXML is focused on exchanging building geometry and thermal related data between disparate software tools involved with commercial building energy modeling and other analysis. However, interestingly, the latest version of BuildingSync XML, there are references to gbXML geometric elements. So this means that if a Revit file exists for a building that a BuildingSync XML references, then a corresponding gbXML file could be created from that Revit file, and all of that 3D geometry in the gbXML file can be referenced from the BuildingSync file. So one example of a use case is a tool that imports a BuildingSync XML and extracts all the measures and utility data, could also import the geometry and display a 3D model of that building in that same software tool. So I really love this slide. This also came from that NREL presentation. Semantics. It's the study of the meaning of language. For example, the word destination and the phrase last stop technically mean the same thing, but students of semantics will analyze their subtle shades of meaning. So as applies to interoperability, the same element in an XML schema that exists in two different schemas may actually mean two different things. Or a software tool that imports a schema may interpret an element in a different way than what was originally intended. So this explains the challenges of interoperability. And finally, there's more than just gbXML and BuildingSync XML out there, as probably most of you know. And as you can see, there's actually a whole slew of schemas that are involved with different stages of the building lifecycle. But today, we're focused solely on gbXML and BuildingSync XML. All right, so let's get started with the demos. So first of all, I'd like to introduce the team from EDSL Tas. Michael Sawford is the Vice President of EDSL and a building simulation specialist. He is passionate about advancing simulation tools and integrating simulation into the design process. Robert Yori is Director of Business Development for EDSL USA. He focuses on opportunities for technology to improve practice, project outcome, and businesses. So I will be passing it on to Michael to demo, and then Robert will be speaking. So Michael, I will make you the presenter.
Perfect. Great. So thank you very much, Stephen. This is Robert Yori. I'm just going to give just a brief introduction, and then I'll hand it off to my colleague, Michael Sawford, for the actual demo. So thank you very much again, Stephen, for inviting us to do the webinar, and thanks to everyone who's attending. We just want to go over a little bit about our BIM to BIM interoperability. But first, I'll give you a general overview of TAS if you're not familiar with it. So we've included the ASHRAE 209 design stages in this slide, just to sort of contextualize what TAS, the scope of what TAS is capable of. Up top, we've got sort of the categories of analysis that our application performs. And of course, then we can map them all to the whole building energy simulation stages as outlined in ASHRAE 209. But briefly, we're capable of doing massing and orientation studies, solar and shading, daylight and glare, envelope and facade studies, natural ventilation, thermal comfort, and finally HVAC design and simulation. So in essence, we're capable of going across the entire spectrum. In addition to ASHRAE 209, we are also capable of doing load calculation and HVAC sizing and detailed HVAC system design. Just a few examples of what you can expect to see from our software. You'll see the actual demo in a few minutes. Here was a study that we did for a conference up in Boston a couple of years ago now. We thought it would be fun to model sort of an iconic Massachusetts building. This is Baker House at MIT by Alvar Aalto. Just a quick demonstration of some of the graphics and analyses that you can get. This is one of annual installation for the dorm rooms. Just a shading assessment and a study of radiant gains in temperatures on an office building. So here we're sort of highlighting the comfort level in terms of temperature range on the left in that temperature band. But we're comparing the zone dry bulb and zone operative temperatures. So very clearly, the zone dry bulb results, if viewed alone, might be able to tell you that those corners are perfectly suitable and within the comfort range. But when you pull in the zone operative data, then you can begin to see that you may have uncovered some problems that you might not have otherwise seen. TAS is capable of any number of graphing and results analyses. We have an application that provides you with a very quick way to get some useful graphs out. And again, you can pivot this data in a number of different ways. This is just a highlight of one of our screenshots that shows the predefined tabs that you can get in terms of the analyses, whether you want to look at the summaries, the loads, demand loads, consumptions, and so forth. Then also, again, you can choose to analyze this data in any level of granularity, whether you're looking for annual all the way down to hourly, and then a couple of different options for how to view the data, whether you're dividing it by floor area for UI or a couple of different visualization options. Again, this is all just within software. Finally, just to conclude our brief overview, the data that's generated in TAS, the calculations that are performed, the visualizations are tied 100% to the data. So any graphic that you see in TAS is a result of the underlying data that's been calculated. So we're providing an environment where you can get visual and data-oriented representations, whether you're using them into TAS or you can take them to other applications very easily. So as Stephen mentioned, gbXML is all about interoperability. So it's one of our key tenets when we're developing TAS. We understand that there are many tools out there. And we also recognize that we make TAS so that it's capable of being perhaps the primary tool of choice, but we understand among project teams that's not always possible. So we want to make it as friendly as possible to work within the toolbox as possible. So for today, we're going to highlight how you can be interoperable with the geometry in gbXML, specifically in terms of geometry creation and then overlaying energy analysis data on top of it. So we've given similar presentations in the past, and we just want to make it clear that you are perfectly capable of creating geometry natively and easily in Tas. We have a whole module that's devoted towards 3D modeling and shading calculations. So that's always an option. But we realize that in any energy modeler engineer's mind, there's always this question when you receive information, let's say from an architect, and that's, is it going to be more efficient to take the geometry and bring it in and perhaps correct or adjust the geometry, or is it simpler to model it from scratch? So in a perfect world, the answer is always get the geometry and reuse it. But I think sort of reality, just in terms of the way platforms work, that's maybe not always the option that people go with. So we want to make sure that you know that there's an opportunity to do both. Model it natively, or you can bring it in through gbXML. And we'll show this in the context of Revit. So I'm going to hand it off to my colleague, Michael Sawford, and he'll take you through the demonstration. Thank you, Michael.
Thanks, Bob. Hope everyone can hear me okay. So I'm going to just do a brief overview of the two workflows we're going to highlight today in the demonstration for the gbXML options for geometry and some other options with 3D DWG data import as well. So the first workflow piece is assuming you get a gbXML file from a BIM model, Revit or otherwise, and that can be imported into Tas. The next step, usually for an energy modeler, is add remaining data in order to conduct some kind of analysis. And then at a later point in time, once analysis has been done, weeks pass, maybe it's later the same day, who knows how often the gbXMLs get updated, you get a new gbXML with new data in it. And the idea of the first part of the demo is we're showing that you can import gbXML, the updated gbXML in, retain the data you've already added to your Tas model, and then go on to conduct the analysis. Maybe if there's brand new spaces, they need more data to be added, but you will keep all the data you added before when you did the middle step. That's the first demonstration will be the import and then re-import and merge of new gbXML data. The second demo is around shade surface imports and being able to merge that data in as well. So for this workflow, assuming you have geometry in Tas from some way, maybe from gbXML, and then that's basically in the gbXML import, a common thing to be missing are shading surfaces. So knowing that that's absent, you have to add data to complete your analysis anyway, but with either by drawing in shade surfaces within Tas is one way of fixing it, but the method we're going to show in the demonstration today is being able to import those shade surfaces through a DWG import and merge, merging with the gbXML file that's already in Tas to obtain that missing information and the impacts those shade surfaces have on the model. So to start the demonstration for the gbXML import and merge, the first thing we do in our 3D modeling application is import the gbXML file. So I'm just going to navigate to our starting project. This is a very typical one many may have seen before. The tab that first opens up is the gbXML preview view, which contains this gbXML file dialog and a list of all the spaces that were in the gbXML that are coming in through the import. There's also several display options for toggling on and off the different surface types that have come in from the gbXML, so you can start to understand it in this preview viewer before you import it. There's also a little report here that says, so in this example, 26 surfaces have been reversed due to inconsistent gbXML data. So we have algorithms that heal and correct the gbXML as it imports to. So if I go ahead and import the file, there's an overall report at the end and an assumption about a surface that was internal. And the idea is that we now have our model in Tas, and we can go on to create an analytical model which has all those same spaces in the software that we saw come in with the gbXML. If I expand this and open up the 3D analytical model view, you can see the geometry is the same, but there's an absence of all of the data. We can still use this view to interrogate the spaces that have come in make sure they're okay, and also interrogate the services that came in from the gbXML to make sure those are all in the same, in the right places as well. At this point, you would add more data, occupants, equipment, lighting, game profiles, material and construction definitions to the services, maybe weather data, maybe aperture functions for natural ventilation analysis, etc. So you have, in the end, you have a complete model ready to simulate. So if we go ahead and simulate now this completed BIM model, BEM model from the gbXML import, this is just to show that we can complete that middle step in that workflow. We can use the 3D preview of the analytical model again to see the results displayed onto the building. And just to show something, let's pick some time in the middle of May, and see as you mouse over these spaces, you can see the dry bulb being reported and calculated for these spaces. So at this point in this process, we've gone through one run of our gbXML import, added data, done some analysis. Now we're going to go back and import an updated gbXML model from the same file, retain the data, and complete analysis again. So we go back to File, Import gbXML. This time we're going to pick this later extension option that came from gbXML. And again, in the preview, before it's imported, you can see what's happened. We have a new piece of geometry here on the right-hand side. If I scroll down through the rooms, you can see there are 3 new ones on the bottom. And again, at the top, we have a report of the surfaces that have been healed during the potential import process. We'll get a report of the final thing once we import this in. So here we go. Now our task model has been updated and merged with the new gbXML. Report of the surfaces that have been fixed and healed. The next step we can do is create the analytical model, but first I want to use our set zone option to basically highlight zones in the model and see if I can find just the zone that maybe not new, but has actually changed in the merge process too. So as I select zones in this list, you'll see them highlighted in the geometry. And if I get to one in particular, there's a few here that have actually been extended. Here you go, 17 corridor is actually the zone that was applied has actually been extended into the new area as well. So not only do we have 3 new rooms that came from the gbXML, we actually have new services in existing zones in the 3D model too. So now I'm going to go ahead and export this analytical model with the new shading calculations into our existing task model and make sure that I do merge to keep the data that we already added. This will run through into our shading calculation analysis to create our new building simulator file. And in here, I can open up that 3D previewer again to see that the analytical model, yep, the geometry has been updated. We've already got annual insolation and sunlight availability analysis available just from the weather data. The weather data is also still there. If I go to the building elements, you can see the list of elements still have all the constructions applied for the material definitions. If you go to the zone list, we can see all the internal conditions, so occupancy gains are all still there. Just the 3 new zones that were added don't have that data. So we can drag and drop the office condition for Saturday, Sunday, and weekday, just for this example, to complete the internal gains profiles for those spaces. Constructions, as we saw, were good. So now this is already ready to re-simulate. So I can just save, simulate my file. So I'll give this a new name just so I can compare the 2 if I wanted. Go before and after. Simulate the file and get to the last step in that first workflow diagram where we have now done some analysis and simplified because you could go on to do any number of lead or ASHRAE analysis. If I just go back to the same day and time, we can see the impacts on the new spaces that have been added ready for analysis while retaining the weather data you can see in the solar shading arc. So that completes the first part of the demonstration. The second part is moving on to do getting in the missing shading information from gbXML imports. So in this, we're going to start in the same manner, opening up our 3D modeling application and importing a new gbXML for a different project. This one's a bit more complex in geometry. So we'll go here, navigate to pick the gbXML and import the file. Here, and then we have the preview come up with all of the spaces on the right, and just navigate around so you can get a feel for the geometry, what's included. And the report this time for the preview is there's no fixes needed done this time, but there is some missing information. So again, here's the list of all the spaces that came in with the gbXML. We can preview each one of those individually in the 3D view if you want. But one thing to note, there are some missing pieces along this area and the edge of this wall. in the Revit model here, you can see there's actually a glass canopy over the entrance doors. There's also some columns supporting an overhang around this corner. And even on the curved walls, there's 3 bands of slats, like 6 or 7 or so slatted shading surfaces that wrap around that wall. So before we get to fixing the absence of those, I'm just going to import the model and do an analysis, shading analysis for that space to see what's happening without those elements in place. So see, once we've done the import, we can see the 3 entrance doors. They all came in okay, but it doesn't have the overhang. The overhang around this corner doesn't have the glass canopy above the entranceway. So I said, before we get on to fixing the problem, I'm going to create the before so we can see the shading data without the fix. If we export this model to create our analytical model in the Building Simulator application, where the building information model was added last time in the previous demo. Wait for the shading calculation to finish. Here we go. So here's our Building Simulator file. I can open up the analytical view again if I want, but here we go. Here are all the zones again imported from gbXML. Here's the geometry that came through from Tas for analysis purposes. Here we already have weather applied. You can see the windows are on the outside and the solar gain arc over the top. If I navigate into that space I want to analyze or double click on it, it'll actually take me to that zone in the TBD in the background. You can see the list of surfaces in this space that are available. By selectively going through these, I can find perhaps the entrance doors and then actually analyze the shading calculation for that surface. So there's the shading calculations for those surfaces. These are done every 15 days. You can see right in the middle of the year, the direct is around 80 or 81% that is exposed without all these shading surfaces. So that's where we're at without accounting for the shading surfaces that are missing in this gbXML. But we still have a bunch of data in the model that can be kept. So if I save this and return back to our geometry tool, we can then import a drawing. In this case, we're going to use a 3D DWG file to import the roof plan again. So here's actually a 2D view of the whole of the 3D DWG file. This includes a few of the layers that were specified there. In the 3D import tab, there is actually an option to display 3D view to choose to see this in 3D, but I do need to set the Z mapping info to map the height of this to the project. This is by comparing the Revit model and how it came into Tas. And once I've set the Z mapping to make sure it comes in the right altitude, I can import this and merge it with the model. In this case, we actually have too many surfaces. We want to make sure we filter that either before or after, but I'll get to that in a second. The first thing I do notice about the canopy obviously is it's not glazed. So we can correct that after we've imported this surface. So this is supposed to be a glass canopy over the 3 entrance doors. So if I go to my building elements list, again, these are all created by the gbXML. I can create a new one in Tas. Just name this glass canopy. Make this a transparent building element, which picks up default properties for a transparent surface. We can customize those as we want within the 3D modeler for analysis. Once I've selected that building element in the 3D view, I can actually then apply this to the surfaces. And now I have that glass canopy back in with a little metal trim perhaps around the outside, making it have an opaque edge but transparent middle portion. So now that's corrected. The larger model though, we have the overhangs, we have the glass canopy, and we have those bands of shades around the edge, but we do have all these other roof surfaces that we don't need. So if I filter out the rest of the task model in the floor plan, the story view, to show just those imported surfaces, we have a couple methods of correcting these. I can literally use the select surface tool to select surfaces and delete them at one by one. I can do a marquee select multiple surfaces at the same time, and then delete those out as well. But there are a few ways of editing the imported surfaces. Some are preferred and others are a bit more arduous. So you could fix this in Revit by creating an exported view from Revit that has just the surfaces you need. And that gbXML, that DWG that gets exported would be exactly what you needed to bring to Tas with no further editing. If you don't have control of the Revit model, maybe you get the 3D DWG with too much information, you could open that up in AutoCAD, fix it there, and then import the 3D DWG with just the surfaces needed to complete the BEM analysis in Tas. Or as we're doing here, start to delete the surfaces within the software in Tas and leave the surfaces you just need. The end result being you end up with those bands of slatted fins around the 2 curved walls, the glass canopy over the entrance, and these overhangs of the columns around this end of the model. So now if I just turn these back, all these other stories on for context, you can see it's now in the finished model, and we just have the bits we're missing, and we can have a look to see if this is actually doing what we expect in Tas before we even get to the analytical model. So if I want to, I can create a daylight view and run some shading analysis and just see how these new surfaces are interacting with the model. So here we go, is the daylight we created, turn the shadows on, we'll see this render out, and you can see that we have that the opaque edge trimmed to the glass that even has a shadow cast on the overhang above it to the right-hand side. On the left, those slatted fins that are in an arc around the curved part of the building, it's casting shadow onto that. You have the shadows from the columns, and obviously the glass is transparent, but not complete 100% transparent. So I said, once we've got this finished, we can now generate our analytical model in the building simulator and export our shading calculations. So I'm just going to export this and make sure again I merge the data in with the existing model that we saw already. This will redo the shading calculations with the impacts of all these new shade surfaces taken into account. Just let this finish. So when we get to the building simulator, expand that and have a look at our the 3D visualization view. And again, we can see all the data still here. We can have a look at that end of the model. You'll notice in the analytical model, the surfaces they aren't included in the analytical model, but the effects of those new surfaces have been taken into account. So again, we can double click on this lobby area, navigate to the same door surfaces, and see if we can see the difference in the shading calculations that performed and the impact on the model. So very much so. So it came down from 81% to about 38 in the middle of the year. So it was an easier way of getting all that data into Tas to take into account the impact of the shading surfaces. The 3D DWG import could be used for surrounding context models, for surrounding buildings, all the way down to very small, say like light shelves within the space, or like as we've done here, some shades and external canopies. The end result though, is we've kept all the data we already had in the model and we just added to it with the merge features and functionality. So in summary, the first part of the demonstration, we covered importing gbXML and then re-importing and merging an updated gbXML file, retaining the data we already had in the file, and conducting further analysis. And then for the second part of the demonstration, we had a file, but the gbXML didn't include the shade surfaces, and it led to some overexposed surfaces for the daylighting analysis and the shading analysis that would impact the energy analysis downstream. And we imported a 3D DWG file, merged that with the geometry to take those shading surfaces into account for analysis purposes. So that concludes the demonstration for today. So Tas is one tool for building simulation sizing, user-centric design. It's easy to learn with some free online training resources. If people would like a trial, they can get that from the website. If people do have any questions about the gbXML import and merge process or the 3D DWG import merge process, please get in touch and contact either myself or Robert, or just go to the support email address on our website or use the contact form, and please get in touch. And thank you for all your time. Thanks for watching.
All right, thanks a lot. Excuse me. Thanks a lot, Robert and Michael. That was great. So I will now show my screen. All right, so now I'd like to present the second demo by Matt Brown of SimuWatt. So Matt Brown is the Chief Product Officer and co-founder of SimuWatt. Mr. Brown has led SimuWatt's product ideation from company inception to leads, continuing development and product expansion of SimuWatt software product and tools. Mr. Brown has over 11 years of experience in product management, software development, and energy efficiency from his time at Concept 3D, Google SketchUp, and Google Earth. So I would like to pass this on to Matt.
Great, thanks, Stephen. Appreciate the introduction. Thank you for having us, and thank you to everybody for joining today in this session. I'm going to go ahead and share my screen. Stephen, are you able to? Okay. Great. Okay, terrific. So we're going to shift gears a little bit into a problem with owners, and a large owner at that, in terms of how do they work with the data they have on their buildings, how do they work with information they're getting from engineers like many of you on this call, and do that in an efficient way to allow for them to better plan and invest in their portfolios. So today what we're going to focus on is a walkthrough of the New York City municipal market, specifically municipal owned buildings and leased buildings, and the different challenges that they face. We'll go through a few slides, followed by a demonstration of the product on how the software is used in their context. So let's just quickly step back and look at some of the challenges the municipality has. They have a lot of buildings, a lot of square footage to deal with, and they have many people who are managing those, whether it's the centralized energy management team for the city, outward to the individual energy managers who are managing those different agencies and different portions of the overall portfolio. So a lot of data, a lot of people, a lot of knowledge, and that's not even including any outside vendors who are involved in the compliance process. So if we're looking at local compliance ordinances for benchmarking energy audits, new greenhouse gas emission caps that are already in place and ultimately result in fines to building owners in the city as of 2024. There's a variety of things that they have to think about. They're not impacted by the fines, just to be clear. Just want to make sure you're aware that the market is paying attention, and they're passing ordinances that is requiring building owners to take action. Now, the city itself, in alignment with those compliance requirements, they're being, they're trying to do their part in being a catalyst for improving the city. They are working alongside overarching city sustainability goals, different phases of that, the big one, 80 by 50, and they have a good amount of budget to work with. And they've developed internal programs to help to fund different projects across their portfolio, but ultimately for them to understand the total opportunity on their portfolio, understand how they're performing, how well they're aligning with those city goals, and if they're effectively investing in the portfolio alongside the vendors they work with on the compliance front. It's too much data for them to really work with. It's too overwhelming. It's disparate information that's scattered, and the formats we get are stored in different ways. So what buildee does is we bring that together as well as other information that's involved in those different processes. So we bring in Con Ed incentives, national grid incentives, for them to be able to see what the implications of different measures that have already previously been identified or their own staff has identified, how those might come into play in terms of helping to subsidize their project development. We folded in the New York State TRM, so we have a standard calculation methodology that's being leveraged for that market. For them, they want to make sure they're having apples to apples comparisons as they're looking at different parts of their portfolio. Now, to facilitate identifying those measures and the different opportunities across their assets, we have product data easily available to access. A lot of ultimately their vendors who are doing site visits or their own internal engineering teams can quickly identify the energy properties of different types of equipment in those existing buildings. We have built-in standardization. So as we look at interoperability and even gbXML, BSXML, our business as a whole is aligned with using standards that are in the market that are being leveraged today to help to continue that interoperability even beyond our own product. So we can bring in, we've brought in standards tools in terms of interconnecting with Energy Star. We've brought in ASHRAE standard methodologies and also an infrastructure aligned with BuildingSync that allows us to have data that can be passed to other tools or bring data from other tools into buildee. So for them, having the standards built in for them to solve for their compliance problems is going to be critical. Now, those standards we're seeing in other markets as well. So just want to make sure this is clear. It's not just a New York problem. You've probably seen there's over 40 different markets involved with benchmarking ordinances and others with energy auditing ordinances. Looking at, even Los Angeles was one that was recent. And then we can bring data together also from third-party products, third-party databases to have a starting point. Ultimately, a lot of people are touching buildings for different purposes, and that information is just not reusable in many cases, or there's a lot of duplicate effort that ultimately comes to the cost of the customer that hits their budgets where they could be effectively investing that into their portfolio. So with buildee, we're bringing all of this data and people here in New York, their vendors, together to simplify benchmarking processes, asset tracking, condition assessments, energy assessments, compliance, budget planning, as they're looking outward to be proactive about where they're going to invest those dollars, and then ultimately keeping track of what opportunities exist, what have we executed on, how are we improving upon it. At the root of this, many of you are probably familiar with how often with the existing building space, a lot of energy assessments, if they're not tied to a specific project being developed, a lot of those end up on paper and they end up in a drawer somewhere. So this empowers those owners to take that information and actually execute and track against it. So as we look at their case, the energy management teams work with their own internal staff engineers as well as external providers to look at the compliance problem. So if we look at New York specific compliance problem here, there's even further compliance beyond these, but the areas where we're tackling with them today, this is getting into the integration with Energy Star Portfolio Manager to simplify the exchange of data and benchmarking, having automation built around that. We provide tools for on-site assessments, energy analysis, measure analysis, report generation through our authoring tools, as well as in light of the specific presentation, a means to get that data out in other reporting environments that are going to be required. So being able to take this out to the asset score tool by way of a BuildingSync file through an export import process. And then lastly, being able to even generate documents to support retro commissioning requirements. So, ultimately this, standardizes a process with New York in alignment with industry standards, as well as provides, ultimately a more simplified approach to solving for these regular assessments that have to be performed or benchmarking that has to be performed. With that, presents opportunities for time savings, cost savings related to those activities, as well as having that data be useful at the end of that process. So let's jump into an example of how this works in buildee. So when we look at New York City, they're able to divide up their portfolio into different agencies and have different teams focused on solving for their own unique challenges. So think of the energy managers who are involved. We can also connect outside vendors into the system as well to gain access to individual buildings. So again, this brings all the stakeholders to the table to exchange information. Now, with that information being in place, energy managers or budget planners can ultimately look at how these portfolios are performing across the board, where they're spending, what their emissions look like, as well as where do they have a pipeline of different opportunities, measures identified by engineering teams, where are those projects in motion, where are opportunities again to invest in the portfolio. Where are we investing in terms of the types of information we're working with, and even being able to drill into where these opportunities are, again, decision-making processes as they're trying to allocate annual budget, and opportunities and backing behind each one of these different measures that have been supplied by those different teams and how they're executed through different projects. So there's a way for, again, ultimately for all of the data to bubble up for the decision makers, which is a critical part of our product offering. Now, how does that data get there? So as we discussed before, we're bringing in information from other systems, their databases, applications. We're also providing tools to manage these buildings directly. So whether that's internal teams that at New York that are looking at individual buildings or doing some kind of measure hunting in buildings, or if it's external vendors, or if it's somebody who's just looking at the load profiles of these different buildings across the portfolio, we provide a home to work with that data. So within each building, they're able to keep track of those things. Here's a firehouse, for example. They had sent out engineering teams to the field to go and collect data on this firehouse, including leveraging the existing utility data that they had brought into the system to analyze this building, being able to look at your typical kind of utility information, as well as being able to go out to the field and collect data about that property specifically. We have a way to manage different assets involved, and these are required as a part of that ASHRAE Level 2 reporting, and ultimately the reporting by way of the asset score tool. Everything that we've seen so far plus this. So this gives you a way to manage the collection of all this data on site, inventory that information, and that can take place using our native application. Allows you to work offline, get into those hard to reach places from a connectivity perspective, manage building data, inventory information on the site assessments, and then be able to even be able to add other equipment from our library. We have an integrated library of different equipment, nameplate information, as well as typical light fixture codes. So you can go out and look for a specific train unit. You'll find a DX unit here by model number while we're out in the field. And this is going to come with built-in nameplate data, but give you a simple interface to collect all that information while you're in the field, going through that process and capturing images of that equipment. Now that information again gets centralized. Now anybody can use this. In New York's case, again, this comes from, in this particular case, from that internal team. It could have come from a vendor who was doing a facility condition assessment, which they're doing some of that work now. Or it could come from a specific vendor who's trying to help them with their compliance activities. Now, this information, again, we store equipment information. We store all the spaces in the building, we call them locations here. Also allow you to build up the different systems you might find on site from common system types. These might look familiar to you if you're familiar with BSXML. And then we can leverage that for measure assessment. So you'll see there's some different measures identified here. Those are coming in from a library of measures you can access directly from buildee. We have a public library of different incentives available in the market, as well as generic analyses for energy savings, from lighting to heating and cooling. These are kind of simple swap out or simple controls methods. And we also provide an environment to house your own. So New York has their own standard approach to solving for their measure analyses. You'll even see we've integrated the New York State TRM directly into the system for them to leverage to perform those analyses, identify what the opportunity is so that they can move that into a funnel of developing projects. Now, through this process, we've collected a lot of information that's going to help those different parties involved down on the engineer side of the fence. The level 2 analysis then can be output to let's start with the benchmarking information can actually be interconnected directly with Energy Star. So as a starting point, if you never got the utility data from the customer, you could always import that data here. You could also export it to support their compliance activities. The other thing is you can take all of the data that we have put together here and output to different report formats. We have a report authoring tool set where you can design your own reports for anything you can dream up from the data we have. So if it's just a general performance report, a benchmarking report, level 1 report, level 2 report, level 3 as far as we can get on those, as well as anything else in between. We work with the utility space as well, who have their own unique flavor of reports. Those different types of reports can be designed. You can also get them directly from us in pre-built reports we provide, and those are going to come out in Microsoft Word. You can also create Microsoft Excel reports if you're looking to get this data out and do analysis somewhere else. And then you can also get a BSXML file as well to import to the asset score tool. So let's start really quickly with the document side. What we can do here, and I'm going to go through this pretty quickly, we're able to take photographs already built in and automatically compile those in different sections of the document, your executive summary tables. We also do your typical 3-year energy consumption analysis with integrated weather information, degree day information already in the product to be able to supply these in those level 2 types of assessments. We also integrate benchmarking data, perform end-use breakdowns, and ultimately even the energy savings by end use, by EUI, by GHG. There's over 27 different visual metrics that you can report against there. Now, on the BSXML side, we can download a file that is going to give us the ability to go over to the Energy Asset Score tool that Stephen mentioned earlier in the conversation. This is where that city, again, has a requirement for everyone to take essentially what they've already put into a report and copy it into another software platform. So we simplify that effort and reduce that really duplicated effort, frankly, by providing a BSXML file output from buildee that I showed just a moment ago, and then the ability just to go and import that data directly into the Energy Asset Score tool. Now, the city ultimately is compiling all of this information for compliance tracking purposes, also using it in the context of the asset score for other purposes of their own. But we're able to bring that in and then populate the fields directly within the asset score, again, reducing that time to getting this information in, while still having that original data set for us to reuse and repurpose over time to manage that portfolio and ultimately identify where we can make investments and how that, again, the engineering team is directly connected upstream with the decision makers through that funding process. So with that, just considering time, I'm going to go ahead and wrap up with this. If you have any other questions on the product, we only showed a subset of the features today. If you have any other questions or like a deeper dive demonstration with us, don't hesitate to reach out directly, and we'd be happy to schedule a time to get together. Thank you again. Appreciate your time and sitting through my presentation. I'm going to hand it back to Stephen.
All right. Thank you very much, Matt. All right, so we have about 5 minutes left for some Q&A. So we actually received a couple of questions during the registration process, so I'm going to read some of those. And if you do have any questions right now, please post them in the question applet, and I will get to those and forward them to the appropriate people. So one question that we got during the registration, and this is for Matt, you may have already, you kind of already covered this, but I do want to ask it. So does buildee have equipment libraries and calculation modeling tools to provide accurate results for mechanical and HVAC ECMs? And Matt, make sure to unmute yourself. Thanks.
Yeah. So our equipment library that we demonstrated from the field covers over 165,000 different nameplates, as well as generic lighting, light fixture codes for assessing lighting. On the measure side, we have over 60 different national level types of energy savings analysis calculations, lighting, heating, cooling, your domestic water, a variety of different things. Those are all coming from standard sources, ASHRAE, NREL, some of the other labs. We also have market-specific TRMs that we're starting to build out. We have New York, Colorado. We're working on California, heading out to some of the Western markets. And We also incorporate different incentive programs in key markets in the coastal environments.
Great, thanks, Matt. And Matt, stay on the line. Another question is, how will buildee incorporate the existing utilities energy efficiency incentives?
So for any measure that you apply, you can look up those different measures that might apply to your project. We give you the, depending on what the utility program is, we'll provide more information about the requirements of that program to capture those rebates, as well as the savings that could be captured as a part of that specific measure that you're looking to apply. Now, for some of our customers, we walked through New York today, but we work with utilities directly as well as implementers. We can build, in some of those cases, we've just built in those calculations into their specific measures. So when they're going through their recommendation workflow with their end customer, that's a part of their process, and they're able to calculate those things on the fly and give them to the customer.
Okay, thanks, Matt. And another question for you, Matt. Is buildee able to create an energy model and run simulations using the data provided?
So prior to buildee, we had another product that we called SemiWatt that came out of a relationship we've had with NREL for the last 10 years. We have technology from that previous product to translate this data into a Open Studio model, an Energy Plus model, with some simple geometric approaches that are, again, focused on less complex building design and simple automation. We have not brought that, exposed that in the new buildee product yet, but we are actually working with a customer right now on how we can leverage that. That will come in the future, and we'll provide more information to the market at that time.
Okay, great. And another question for you, Matt. Is buildee applicable and useful to other countries beyond the US?
It is applicable. We are currently focused on the US market, and in US units, I guess, are kind of hybrid set of units that we have here. But we are thinking about expanding to other markets. If you are, I guess, wherever this question is coming from, if you want to send a follow-up, we'd love to learn more about your specific problem, because we're looking for a good customer to get that in motion.
All right, great. So actually that is, we reached our time limit. It's 11 o'clock Pacific time. So I want to thank both companies for presenting. I thought it was fascinating and a lot of great information, great software tools out there. My contact information is on your screen right now, so feel free, if you do have additional questions, please forward them to me, and then I will forward them to the appropriate individuals. Also, I will be posting a recording of this webinar on YouTube and sending the link out to everyone who attended within probably by the end of the week. So once again, thank you all for attending, and thank you to our presenters, and have a great day.
Thank you, Stephen. Thank you, everyone.